China says it expects to build more than 100,000 humanoid robots this year. Not robot arms, not little delivery machines. Human-shaped machines with legs, arms, and hands. Near Beijing, one new factory says final assembly can release roughly one humanoid every 15 minutes. And one Chinese robotics company says its 15,000th robot already rolled off the line in June. Another shock comes from price. Unitree lists its G1 from about $13,500. But don't picture 100,000 flawless robotic employees walking into factories tomorrow. Today's humanoids still fall, lose balance, misread objects, and run out of battery. What matters is what happens when imperfect machines begin improving at manufacturing scale. China already installed 295,000 industrial robots in 202,454% of the world's total. So humanoids aren't entering an empty market. They're entering the world's largest industrial robot ecosystem. America's racing too, and that's what makes the next few years especially interesting. The real question isn't whether robots can dance. It's what happens when AI finally gets a body. First, understand the 100 to 1,000 number correctly. It's an output forecast, not 100,000 autonomous workers. Production, shipment, deployment, and productive autonomous work are four very different stages. China also says it has developed more than 400 complete humanoid robot products, over half the global total. That doesn't mean 400 winners. It means hundreds of teams are trying different solutions. Some robots are built for factories. Others target research, logistics, retail, or human interaction. The variety matters because nobody yet knows which humanoid design will become dominant. Now, compare humanoids with the automation China already uses every day. In 2024, factories worldwide installed about 542,000 industrial robots. China alone installed about 295,000 more than every other country's contribution combined. Its operating stock of industrial robots had already passed 2 million. America isn't unautomated. U.S. factories installed roughly 38,000 industrial robots in 2025, up 11%. Here's the twist. U.S. manufacturing actually has more industrial robots per worker than China. IFR puts the U.S. at 307 robots per 10,000 manufacturing workers versus China's 166. So the story isn't simply China automated, America didn't. Reality is much more interesting. America currently has higher robot density. China has astonishing absolute manufacturing scale. And humanoid robots could turn that manufacturing scale into something new. Physical AI, produced like hardware. To understand why that matters, we need to ask a stranger question. Why build robots like humans? A fixed robot arm can be faster, stronger, cheaper, and more precise than a humanoid. Wheels are usually more efficient than legs. Conveyors beat humans at moving identical objects repeatedly. So the human body isn't being copied because it's mechanically perfect. It's being copied because the world around us was already designed for humans. Door handles assume our reach. Stairs assume our legs. Tools assume our hands. Factory benches, shelves, and carts were positioned around human bodies decades before humanoids existed. A truly capable humanoid could theoretically enter these spaces without rebuilding the entire factory around it. That's the promise. But turning a humanoid into a useful worker requires solving an absurd number of engineering problems. Every joint needs actuators, bearings, control electronics, and mechanical parts that survive thousands of repeated movements. Every step needs balance calculations happening quickly enough to stop a very expensive machine from falling. Every useful hand must combine strength with something machines historically struggle with: delicate touch. Cameras and depth sensors must identify a world that never stays perfectly organized. Batteries must carry enough energy without making the machine too heavy to move efficiently. And software must coordinate all of it in milliseconds. China doesn't have a magical shortcut around those problems. It has something more practical, an enormous manufacturing network. Motors, batteries, electronics, machined parts, and sensors can move through mature supplier networks built for other industries. That proximity can shorten the brutal cycle between designing a component, building it, testing it, and changing it again. China's current national industrial strategy now places AI-powered robotics near the center of future manufacturing. But government attention cannot make a bad robot commercially useful. factories still demand reliability and economics. That's why the new Beijing area production plant is more interesting than another robot dance video. Beijing reporting says its final assembly line can release roughly one humanoid every 15 minutes. Again, that's final assembly cadence, not mining metal. Machining every part and building a robot from scratch in 15 minutes. The plant separates component production, module testing, final assembly, and full machine inspection. Newly built arms and legs are tested before they're attached to complete machines. Torque monitoring checks assembly while adjustable workstations accommodate different body sections. The factory's stated target is 10,000 units in 2026. It plans to reach 20,000 in 2027, and the long-range plan points toward 500,000 units of annual capacity by 2030. Those are plans, not guarantees. Demand and robot performance still have to justify building that many. But even planned capacity tells us what manufacturers believe the next phase could look like. They aren't planning to hand-build a few laboratory curiosities. They're preparing for an industry. And scale attacks one of humanoid robotics' biggest barriers: cost. Unitree currently lists its G1 humanoid from about $13,500 before extras, tax, and shipping. The G1 weighs roughly 35 kilograms, about 77 pounds. Its listed battery endurance is roughly 2 hours, depending on use. And depending on configuration, the platform uses dozens of powered joints to coordinate the entire body. $13,000 does not buy a flawless replacement for a human worker. What it does is lower the cost of putting real hardware into universities, startups, and developer labs. More hardware in more hands means more experiments, more failures, and potentially faster learning. But purchase price is only the first line on a factory's spreadsheet. Businesses also pay for integration, charging, maintenance, software, supervision, and downtime. A cheaper robot that fails constantly can be far more expensive than a costly machine that simply works. That's why the real humanoid race isn't about sticker price. It's about cost per useful task. This is why Agabot's June production milestone deserves attention. The company announced its 15,000th robot. Agibot says moving from its 5,000th to 10,000th unit took only about 3 months. But a production milestone doesn't prove a robot can survive real factory work. So Agibot also ran a 6-day live stream inside an actual tablet production environment. The company reported more than 64 hours of robot operation during the test. It says the robots performed 64,828 production line tasks, and the line produced 17,625 tablets during the period. Agibot reported a 99% task success rate, and that's a company-reported figure, not an independent audit. That distinction is crucial if Snoutwatch wants evidence instead of advertising. Still, the factory environment makes this test more useful than a perfectly controlled stage demonstration. Real lines contain moving materials, human coworkers, changing positions, and interruptions that laboratories can remove. That shift from performance to deployment is the part of China's robotics story worth watching. Because the hardest problem isn't making a humanoid look impressive for 30 seconds. It's making the same machine succeed, hour after hour, when the world refuses to stay predictable. That's where embodied AI enters the story. A chatbot can be wrong and give you a bad sentence. A robot can be wrong and drop something, or lose balance, or damage equipment, or potentially hurt someone. So, physical AI needs perception, planning, movement, and feedback operating together in real time. One training method is simple in concept. A human demonstrates the action, and the robot records what happened. Repeat that across different objects, angles, lighting, and mistakes, and the dataset becomes far more useful. Simulation can create millions more attempts without smashing physical hardware every time something goes wrong. But simulation never captures every strange detail of the real world. Soft fabric bends, clear plastic reflects light, cables move, boxes arrive crushed, humans stand in unexpected places. Every edge case teaches engineers how far general purpose still is from truly general. This is why today's humanoids deserve both excitement and skepticism. Battery endurance is still tiny compared with a human work shift or fixed industrial equipment. Hands remain one of robotics' most difficult engineering problems. Humans adapt grip force almost unconsciously. Robots need sensing, control, and training to approximate that skill. Vision also fails on things humans barely notice: glare, clutter, occlusion, and objects appearing in strange orientations. Then there is safety. A 70-pound machine with powerful motors cannot behave unpredictably around people. Maintenance matters too. A robot deployed at scale becomes another machine that factories must service. That's why the first useful humanoid jobs are likely to be structured and repetitive. Think material handling, inspection, machine tending, and tasks where the environment can be constrained. Dangerous or ergonomically punishing jobs could be attractive too if the economics work. But a humanoid won't replace a $10,000 fixed machine that already performs one task perfectly. Humanoids become interesting where flexibility is valuable enough to justify their extra complexity. Now bring America back into the picture, because the popular China versus a sleeping America story is wrong. U.S. industrial robot installations rose 11% to about 38,000 in 2025. And remember, America currently has substantially more industrial robots per manufacturing worker than China. China wins the raw volume comparison because its manufacturing system itself is enormous. American humanoid companies are also moving from labs into real industrial environments. Figure says its earlier robot contributed to production involving more than 30,000 BMW vehicles in Spartanburg. In June, Figure's newer Figure 03 returned to that BMW factory for more complex logistics work. Agility Robotics also signed a commercial agreement to deploy Digit with Toyota Motor Manufacturing Canada. Agility's Oregon RoboFab was designed for capacity above 10,000 humanoids per year. So this is not a race where only one country understands the technology. The more useful comparison is scale, cost, reliability, software, and deployment speed. And on those measurements, the result is far from settled. Ultimately, a factory doesn't buy a humanoid because its walking video got 10 million views. It buys one when the machine produces more value than it costs. That means measuring uptime, successful tasks, energy, maintenance, supervision, and the cost of failures. The winning robot may not be the strongest or the one with the most human-looking face. It might simply be the machine that shows up every morning and completes one boring job reliably. That's less exciting than a backflip. For factories, it could be far more valuable. And yes, if the economics work, some human tasks will be automated, especially work that is repetitive, physically punishing, dangerous, or difficult to staff consistently. Other jobs will appear around maintaining, integrating, training, and supervising fleets of machines. The transition won't feel identical to every worker, company, or city. That's why claims that humanoids will either save every job or replace everyone are equally lazy. The real outcome will depend on what these machines can do reliably and economically. So where might China's 100,000 unit year actually lead first? Probably not your living room. Look instead at factories, warehouses, laboratories, and controlled commercial spaces. That's where limited robots can earn value, while engineers collect the data needed to make them less limited. If tens of thousands of machines enter real environments, even imperfect deployments create enormous learning opportunities. More machines can mean more real-world data. More data can improve models. Better models can make hardware more useful. More useful hardware creates demand. Demand can justify larger factories. Larger factories can push costs down. That's the flywheel China is trying to build. Hardware scale feeding AI improvement and AI improvement feeding hardware demand. But flywheels can stall. Poor reliability, weak demand, or high operating costs could slow everything down. So don't measure this race by viral dances. Watch shipments, deployments, uptime, task success, and total operating cost. Watch America too, because competition can accelerate robotics on both sides of the Pacific. The question isn't which country makes the best robot video. It's where useful physical AI reaches scale first. Because the robot that changes the economy may not be the one that dances best. It may be the one that comes back tomorrow and works again.